In reality, section 8.8 and 8.9 are pretty much the same thing. We're factoring perfect square quadratic trinomials and perfect square quadratic binomials. So it says right here, if you have a perfect square term in the leading term and ending term, then maybe you have a perfect square quadratic trinomial or binomial, in which case you can take the square root of each and plug it into your answer format. So we first need to understand when we have a perfect square binomial or perfect square trinomial. And in order to identify that, you need to see a perfect square term right here in the front and a perfect square term right here in the back. Now, if you do have a perfect square term in the front and in the back, you simply take the square root of those values and then plug them into your answer format. So if we think, what's the square root of 25x squared? That's 5x. So that's why both binomials have a 5x right there, because the square root of 25x squared is 5x. And then the square root of 36 is 6. That's why there's two 6s right there on each of the binomials, or 1 6 on each of the binomials. Now, because it's a binomial, not a trinomial, we know that when we distribute, the middle terms have to cancel out. And in order for the middle terms to cancel out, one has to be a positive, one has to be a negative. So that's why there's a plus here and a minus there. And after all, if we look at the last terms that we're multiplying when we distribute, right, like 5x times 5x, 5x times negative 6, but the very last step on distribution, positive 6 times a negative 6, that's how we get that negative 36. And because they're plus and minus, the middle terms cancel out. That's why it's a binomial, not a trinomial. Now over here, notice that the signs are the same. That means that the middle term does not cancel out, okay? And it's important to understand how the signs work. A negative 6 times a negative 6 does give you a positive 36. And with those negative signs, when you combine the middle ones, you will get a negative 60x. So the last tool in our factoring toolbox is to identify when you have a perfect square term in the front and in the back, take the square root, and that might be your answer when you plug it into your answer format. Let's give you a couple of examples here. Let's go with this one. This one looks like a perfect square binomial, right? Why is that? Well, because the square root of 16p squared is what? 4p. And the square root of 36 is what? 6. So I already know the numbers that are going to go inside my binomial. You guys just told me it was 4p and 6. 4p and 6. Now, what symbols belong right here? A plus plus, a minus minus, or a plus minus? Plus minus. And that makes total sense, guys, because a negative 6 times a positive 6 will give you the negative 36 that we have here. And because the signs are different, when we distribute, the middle terms cancel out. Let me show you what I mean by that. 4p times 4p is 16p squared. 4p times 6 is positive 24p. But then a negative 6 times positive 4, that's a negative 24 with the p. And negative 6 times positive 6 is negative 36. And as you can see, those middle terms really do cancel out. So it's important to really understand that the signs have to be different in order for the middle terms to cancel out, which will produce the binomial that we have here. So when you're factoring a binomial, if you have a perfect square term and a perfect square term, you're able to square root them, plug it into your answer format, and they have to be different signs. Now, keep in mind, this has to be a minus. If it's a plus, you cannot do it, okay? Because if it's a plus, then you want a positive 36 at the end of it all. And the only way to get a positive 36, if it were a plus, is to have a plus plus or a minus minus. And neither of those would make the middle term to cancel out. Does that make sense? Okay, so that's the correct factored form. That's one example that we saw. That was a perfect square binomial. Let's take a look at a perfect square trinomial. So right here we have a perfect square trinomial. See, the first method you should always try is to pull out the GCF, right? Like, what's in common in all three terms? Do all three terms have a y? No. Do all three terms have a 4? No. Okay, so you're always supposed to try to factor out the GCF. That's the first tool you should try, but you can't do it. So then you move on to something else. Some of us that don't know this shortcut of perfect square trinomials, are going to go, oh, A times C, 4 times 25, that's step 1, that's 100. And then the multiples of 100 that combine together to give you negative 20. But in reality, you're going to be wasting time. All you have to know is this shortcut. If you really do have a perfect square term here and a perfect square term there, you're able to take the square root of them, plug it into your answer format, and then just check your answer and you're done. So what's the square root of 4y squared? 2y. What's the square root of 25? 5. So we have a 2y at the beginning of the binomials. We have a 5 at the end of the binomials. Now, what signs do you think we're going to have between the terms? A minus and a minus, right? Because negative 5 times negative 5 will get you the positive 25. And when you add the terms together, you will get a negative term in the middle. So let me put the minuses right there. And just to be on the safe side, let's double check and make sure it works. 2y times 2y is 4y squared. 2y times negative 5 is negative 10y. Negative 5 times 2y is negative 10y, and negative 5 times negative 5 is positive 25. And when I combine these two right here, I really do get that negative 20y. So I know I factored it right. I know that those two binomials are the correct answer. By the way, on your worksheets and on some test generators, whenever you have a binomial times itself, kind of like we have right here, we have 2y minus 5 times itself. Another way of writing that, a cleaner way of writing that, would be to put 2y minus 5 and then put a square on it. So this is the same thing as that. So it's totally up to you which one you want to use. But that's how we do the square roots on the perfect square quadratic trinomials. Let's try another one. So on this guy, do we have a perfect square term in the front? Yes. Do we have a perfect square term in the back? Yes, we do, right? So the first thing you should think of is, hey, perfect square terms. Maybe I could square root them and plug them into my answer format. So what is the square root of 25b squared? 5b. What is the square root of 16? 4. So what symbols belong in here? A minus and a minus? What do you guys say? Minus and minus, right? But when we double check it, this is why it's important to double check. I mean, that's our educated guess, but when we double check it, we see it doesn't work out. Check it out. 5b times 5b, 25b squared. 5b times negative 4, that's negative 20b. And then when you go negative 4 times 5b, that's another negative 20b. And negative 4 times negative 4 is positive 16. And as you can see, these middle terms, they don't cancel out. When you combine them, you get negative 40b. And as you can see up here, it's not negative 40b, it's negative 4b. So even though I did have a perfect square term here and a perfect square term there, it did not work out. It did not work out. So right here, it's not factorable. Or it might be factorable. The only other option I have is to multiply a times c, get a huge number, and think of the multiples. But I just wanted to show you an example of just because you have a perfect square term here and a perfect square term there does not mean it's going to work out. You have to check your answers, okay? How about here? Is this a perfect square term? I mean, a perfect square binomial? Is it a perfect square binomial? Could he do the square root of 32? No. Could he do the square root of 18? No. Okay, so it's not a perfect square binomial. So we can't use that shortcut of taking the square root because they're not perfect square terms. But what is the first thing that we should try to do before anything? GCF. So when we pull out the GCF, what would the GCF be? Could I pull out a 4? Could I pull out a 6? What could I pull out? What's in common? 2. That's the only thing I could pull out. What would be left on the inside? 2 times what is 32? 16. Still have the t squared. Minus 2 times what is negative 18? Minus 9 with the u squared. So we pulled out the GCF, and the mistake most commonly made by students is they pull out a GCF and they move on to the next question, right? But the thing is, you're supposed to pull out the GCF and then look at the inside of the parentheses and see if you could continue working. So what else could I do on the inside of the parentheses here? I could actually, because I have a perfect square term in the front and a perfect square term in the back, I technically have a perfect square quadratic binomial. So I could jump to my shortcut, take the square root of 16t squared. What's the square root of 16t squared? 4t. And 4t right there. What's the square root of 9u squared? 3u and 3u. Now, the middle term is a minus, or there is no middle term, so we need the terms to cancel out in the middle. And the only way that's going to happen is if one's a plus and one's a minus. And don't forget about that outside 2. The outside 2 has to come down on your final factored form answer. And that's it right there. So, like always, the first method we learned of factoring was pulling out the GCF. Always try to pull out the GCF first, and then continue working on the inside of the parentheses. Okay, what's up with this guy right here? 16p squared plus 24p plus 9. What could I do first? What could I do first? GCF. What's the GCF, guys? 2? I could pull out a 2 from 9? No? Could I pull out anything? No, so there is no GCF to pull out. Okay, so that was the first tool you're supposed to try to use. That's good. You try to pull out the GCF. There was no GCF. What do we do next? Square roots, right? We could do the perfect square terms and square root them. Now, a lot of us that don't know that trick are going to go to 16 times 9. That would be your first step. Step 2 would be to think of the multiples of that huge number that combine together to give you 24. And you could do that long multi-step process. But thank goodness for these past 2 sections, because we know that if we have a perfect square term here and a perfect square term there, we might be able to factor them by taking the square roots. Square root of 16p squared is what? How about the square root of 9? And what symbols belong in there? Plus, plus. And if you do double check your work, 4p times 4p is 16p squared. 4p times 3 is 12p. 3 times 4p is 12p. And if you add those two 12p's together, you really do get the 24p. So we know that we've factored this correctly. And at the end of it all, also 3 times 3 is the positive 9. So always check your answers. Let's go for a final example here. What do you guys say right here? What could we do? Could we pull out a GCF? No. Could we do anything else? Square root. Okay, we do have a perfect square term right here and right here. However, ladies and gentlemen, in order for you to be able to do this, the middle term has, not the middle term, the sign in between the binomial, sorry. In order for this to work, this has to be a minus sign. Okay, it has to be a minus sign. If it's a plus sign, it won't work. Even if you did the square roots, check it out. What's the square root of 4x squared? 2x. What is the square root of 25? 5. Now, here's the hard part. What symbols belong in here? A minus minus? A plus plus? Because look, the only way at the very end, when you multiply positive 5 times positive 5 to get positive 25, is if both of them are positive or both of them are negative, right? But you know that there's no middle term, which means that one has to be plus, one has to be minus. So you can't figure it out because it's not possible to figure out. So this is not factorable. This is why we say prime. Okay, it just does not work. Okay, prime, it does not work. Let me repeat what I just said a couple of moments ago. In order for it to be a perfect square quadratic binomial, you have to have a minus between the two terms. So if I had 25x squared minus 16, right there you can do it because there's a minus sign between them. So what would that be? What would the answer be right there if I were to factor it? 5x and a 4. 5x and a 4. How about those symbols? 1 plus, 1 negative. Or 1 negative, 1 plus. Doesn't matter. But they have to be different. Because when they're different, the middle term cancels out. There's only 2 terms. Now, if I would have had a plus right here, then I wouldn't be able to do any of this. I would just say prime. Make sense? Okay. there is going to be some equation solving on Friday's test. And when we solve equations, if you do have like a quadratic trinomial or something that you could factor, you want it to be equal to 0. But you could also go back to the old way of solving equations to get x by itself. And the way to get rid of something, you do the opposite. So if you want to get rid of the square on an x, if you wanted to get rid of the square on an x, what would you do? To get rid of a square, what's the opposite of a square? A square root. So if you apply a square root there and apply a square root there, there's this one little rule that we need to learn, that when you apply a square root in an equation, you have to put a plus minus in front of your answer. Okay? So right here, x equals plus or minus 3. The plus or minus is actually two different answers. What it means is that x is equal to 3 and x is also equal to negative 3. So whenever you apply a square root in an equation, you have to put a plus or minus in front of your answer. Now, does that make sense? Why we put a plus or minus? Now let's say you don't really buy it. Let's go back to the original equation. X squared equals 9. Remember, a solution to an equation is the value that makes it a true statement. So instead of x squared, I want to put parentheses squared equals 9. So what number could go in right here? A negative 3 or a positive 3. That's exactly why the answer is not just 3, but it's actually plus or minus 3, because both a negative 3 squared will give you 9, and also a positive 3 squared will give you 9. So it actually has two answers. X equals positive 3 and x equals negative 3. And the better way to write that is with the plus minus sign. X equals plus or minus 3. So the trick to remember here, or the rule to remember here, is when you apply a square root in an equation, you have to put a plus minus in front of your answer. So we will have one of these on the test Friday. So please make sure that you understand what I'm explaining here. So let's take a look at number 2 here. How do I get rid of the square? How do I get rid of this square? By applying what? What's the opposite of a square? Square root. So I want to do a square root there. What I do to one side, I do to the other side. So the square root and the square eliminate themselves. The square root and the square eliminate themselves. So you really do have an x minus 3 left over. You have the equal sign. Now I need to put a plus or minus in front of my answer. So I want to put plus or minus. What is the square root of 25? 5. So I almost have x by itself. I still need to get rid of that minus 3. So I'm going to go plus 3 here, plus 3 there, and I'm going to rewrite it. It's going to say x equals positive 3 plus or minus 5. Now, that is actually two answers. What do I mean by that? That's really saying positive 3 plus 5 and also positive 3 minus 5. So we get two answers. We get one answer that's 8 and the other answer that's negative 2. Okay? So we will have one of these on the test Friday. Make sure you understand, to get rid of a square, you have to apply a square root. But if you do apply a square root when solving an equation, you have to put a plus minus right in front of your answer.